Now let us explore the criteria of an algorithm, because algorithm is a well-defined procedure which consists of a finite set of well-defined instructions. The finite set of well-defined instructions must take the finite amount of storage and the finite amount of executional time to complete the entire execution. Every algorithm must satisfy some criteria. First criteria is input. Input is the first criteria of an algorithm, right? We need to think of how many number of inputs are required, right? How many inputs are required for each algorithm? That is a question. We write the algorithm, right? In this representation, algorithm, then name of the algorithm, say algorithm name, then specify the parameter list. Following that, we can define, in terms of steps. Step 1, step 2, etc. Step n. Or in between this opening and closing curly braces. Instead of writing these steps, we can write the instructions, executable instructions. Parameter list is concerned, these are the formal parameters. Formal parameters, which are simply the external inputs. Formal parameters are external inputs, or we can also provide the inputs in the algorithm itself, these inputs can also be given in the corresponding steps. Input is concerned, how many inputs we are going to supply externally. For example, in the algorithm, a sum and average of 5 numbers, int a, int b, int c, int d, int e. We have defined some formal parameters. In step number 2, we have instructed to input the values of integer variables a, b, c, d, e. So during the runtime, or during the execution of the algorithm, we need to input the values of the input variables a, b, c, d, and e. So at execution time, 5 inputs are required. In case if we have initialized the values of variables in step number 2, for example, in case if we have done the initialization, a is equal to 10, b is 20, c is 30, d is 40, e is 50. Having this initialization of variables in step number 2, during the execution time, we need not input any values of these variables externally. So the inputs can be initialized internally in the corresponding steps, or inputs may be provided at execution time externally. So with respect to the number of external inputs, 0 or more inputs are provided externally. Externally, we can provide 0 or more inputs to the algorithm. When we run or when we execute the algorithm, how many inputs are required, how many inputs are externally required? We can provide externally 0 input or 1 or more inputs externally. Second criteria, output. Output is concerned, Every algorithm must produce at least one quantity as output. At least one quantity as output. For example, the algorithm that we have designed, right, some average outputs are two variables. One is sum and another one is average. Every algorithm must produce at least one quantity as output. At least one output is required when we trace or execute the sequence of steps in the given algorithm. Input, output. Third one is definiteness. Definiteness. Definiteness in the sense that every instruction in the algorithm must be clearly defined. Clearly defined instructions. Every instruction should be clearly defined. That means we should have a set of well defined instructions. What are well defined instructions? When the instructions are executed by the machine should not reach any ambiguous state. For example, if we instruct a system to perform the operation, for example, step I. In step I, if we instruct perform A is equal to A plus B or B is equal to A minus B. Assuming in step number I, we are going to instruct a system to perform the operation. Perform either A is equal to A plus B or B is equal to A minus B. This is an ill-defined instruction, right? This is not a well-defined instruction because we are asking the system to perform any one of these two instructions. Under what situations, right, this instruction is going to be executed, or under what situation second instruction is going to be executed. That should be clearly defined, right? So writing, right, perform this operation or this operation, this is not a definite instruction. This is not a definite instruction. Every instruction must be a defined one, clearly defined one. Clearly defined instructions are placed in the different steps in the algorithm. That means each step focuses on clearly defining the instructions. That means a well-defined instruction, that is a target, so that the system should not reach any ambiguous state. That's what we have defined. Algorithm is an unambiguous procedure. Algorithm is an unambiguous procedure. The unambiguous procedure, right, should have the well-defined set of instructions. So the third criteria is definiteness. Well-defined instructions are required in each step of the algorithm. Fourth criteria, finiteness. Finiteness in the sense that the total number of instructions in the algorithm must be a finite one, because the total number of instructions are a finite one. With respect to space complexity, it takes a finite amount of storage. Finite amount of storage. Finiteness, right, in the sense that total number of instructions should be a finite one, then the amount of storage required to run the given well-defined instructions must be a finite one. Fifth one, above all the previous four criteria, the algorithm should satisfy this criteria. Effectiveness in the sense that every instruction must be very basic. Every instruction must be very basic. Every instruction should have an effect to compute the output variable. For example, here we have defined the total number of steps. For example, 6 steps to find out the sum and average of 5 numbers. Suppose if anyone is writing, say 15 steps to find the sum and average of 5 numbers. In that stage, the total number of steps, 15 steps, step 1, step 2, etc., step 15. Each step should have a worth in computing the sum and average of 5 numbers. In case some steps are x steps are not required in finding the average of sum and average of 5 numbers, then what we have to do means we need to eliminate those unnecessary steps. That means whatever the well defined instruction that we are defining in each step must have an effect to find the final computation, or it should have an effect to find the corresponding value of output variable. That means the input output transformation, the output is focused on the effectiveness of the individual well defined instructions. All instructions should have an effect to achieve the desired input output transformation. That's what algorithm, every algorithm should satisfy this effectiveness criteria. So having these 5 criteria, one is input, second one output, third one definiteness, fourth one finiteness, and the fifth one effectiveness. These are the 5 important criteria of an algorithm. That means whatever the algorithm we want to design to solve the given real world problem, every algorithm must satisfy these criteria: input, output, definiteness, finiteness, and effectiveness. The ultimate target is we need to write the well defined instructions so that the number of well defined instructions should be a finite one, so that finite number of well defined instructions should occupy finite system capacity, finite storage capacity, and finite number of instructions should have the finite amount of computational time, total computational time, that should be a finite one. We have discussed the different criteria of an algorithm: input, output, definiteness, finiteness, and effectiveness. Based on these criteria of an algorithm, we can formulate the properties or characteristics of an algorithm. The first important characteristics: Every algorithm must be precise. We need to specify which instruction, which well-defined instruction is actually required, right? Every instruction, every well-defined instruction should be clearly defined, and it should have the effect, right, to achieve the required input output transformation. Algorithm, right, must be precise. Second one, an algorithm must be effective one. Algorithm must be precise, and algorithm must be an effective one. Third one, an algorithm must have a fixed and finite number of instructions. Fixed and finite number of instructions. Definiteness property, right? Finiteness property, right? A criteria, definiteness and finiteness criteria, right, results in this a characteristic. Every algorithm must have a fixed as well as finite number of instructions. Fourth one, above all, the execution of an algorithm, must always terminate. Suppose an algorithm X is going to be executed by a machine, assuming that the start time is right at t millisecond, or the start time is right at t. Start time is simply at t. After some delta t milliseconds, say at a system time t plus delta t, right? Whatever the value of delta t, which may be a minimal quantity or maximal quantity, or in between minimal and a maximal quantity, right? So after some finite number of days, or finite number of years, finite number of months, or finite days, what will happen means, that means at a time t plus delta t, the algorithm should reach the termination stage after a delta t computational time. That means at time t plus delta t, algorithm should have completed its execution, so that the total computational time is t plus delta t minus t, which is equal to delta t. So above all, the precise effectiveness and having a fixed and finite number of instructions, the execution of an algorithm must always terminate. This is the very important criterion. In case the algorithm is not terminating, assuming that the algorithm is not terminating, then we can't say that is an algorithm, right? Algorithm, right, must terminates after some a finite amount of computational time. That's what the time complexity is very important, right? So time complexity defines how much computational time is required to complete the execution of the given algorithm. So above all, the execution of an algorithm, right, must terminate after the finite amount of computational time. That means the total computational time should be a finite one. These are the properties or characteristics of the given algorithm. An algorithm must be precise, an algorithm must be an effective one, an algorithm must have a fixed finite number of instructions, an algorithm execution, right, must always terminate. We have discussed the different criteria of an algorithm, the different characteristics of an algorithm. Next, we are going to explore the different areas of study of an algorithm. There are different areas of study of an algorithm. First one, how to devise algorithms. How to devise algorithms. Second one, how to validate algorithms. Third one, how to analyze algorithms. Fourth one, how to test programs. These are the some of the areas of study of an algorithm. First one, how to devise algorithms. That means how to design algorithms. Given the real world problem, say P, we need to design the algorithm to find the solution of P. To obtain the solution for the problem P, what we have to do, we need to define the algorithm. That means we need to devise, we need to design the corresponding algorithm. So how to design the algorithm, right? This is an important areas of study. Algorithms can be designed using different design strategies. Different design strategies are applied in designing the algorithm for the given problem. For example, we can apply the divide and conquer strategy, divide and conquer strategy, heuristics strategy, greedy strategy, backtracking strategy. These are some of the algorithm design strategies. Divide and conquer, which is going to be applied when the input size is large. We can divide the input size into smaller problems, and the smaller problems are going to be solved individually, and we can combine the solutions of the individual or sub problems to get the solution of the original problem. Or we can define, right, some heuristic or heuristics to find out the solution to the given problem. We can also apply some greedy like heuristic strategies to obtain the solution to the given problem. We can apply the backtracking strategy to solve the given problem. The design strategies are not limited. Based on the nature of the given problem, we can apply the appropriate design strategy so that we can find the solution to the given problem. So what kind of design strategy is going to be applied, and what are the different design strategies available, right? So learning these, right, we will have one important areas of study called devising algorithms, or how to devise algorithms. Second, right, how to validate algorithms. Once an algorithm is designed, we need to ensure that the algorithm should produce the correct results for all valid inputs. That is said to be algorithm validation, right? Second step says algorithm should be validated. Algorithm validation. Algorithm validation is the process of checking if the algorithm is producing the valid results or correct results for all valid inputs. For example, you consider this algorithm. Algorithm is leap. Suppose int year is given as the input. Assuming that step 1, if year mod 4 is equal to 0, then you can write here, for example, a print leap year, else a print non-leap year. Step 2, stop, or even write step 1 can be split into some steps. Find the value of year mod 4, compute year mod 4. Step 2, if year mod 4 is equal to 0, a print leap year. Else, then there itself, you can call go to this step. Else, go to this step, a print non-leap year. Anyhow, assuming that the well-defined instructions are defined here. If year mod 4 is equal to 0, then print leap year. Else print non-leap year. So consider this an algorithm or the procedure. Suppose we are inputting is leap 2000. The result is leap year. Since 2000 is divisible by 4. Next we are checking is leap, say 2100. What happens? 2100 is divisible by 4, because 2100 100 is divisible by 4. 2100 is divisible by 4. This is a leap year. The result is print leap year. 2100, this is a century year. Century years are leap years if and only if the years are divisible by 400. So in case if we assume this is the optimal algorithm to check if the given year is leap or not, then the algorithm should be validated. Whatever the valid inputs you are given, the algorithm should produce the correct result, that is a valid result. Given the input 2100, since 2100 is not a leap year, since it is a century year, we need to revise the well-defined instructions. That means we need to change the logic of the individual, or we need to change the logic of the well-defined instructions. So since for century years proper check has not been made, the algorithm is not producing the expected result. That is a problem. So this should be changed to, how to change, if year mod 4 is equal to 0 and year mod 100 say not equal to 0. This is one condition. Year mod 4 is equal to 0 and year mod 100 not equal to 0 for non-century years, or for century years it should be divisible by 400. So if you give E sleep of 2400 is divisible by 400. E sleep 3000 is not divisible by 400. So 3000 is not a leap year. 2400 is a leap year. E sleep of 2000 is a leap year, right? After 400 years from 2000. So 2400 is the corresponding century year as well as a leap year. So checking if year mod 4 is equal to 0 and year mod 100 not equal to 0 or logical or year mod 400 say is equal to 0, then we need to write this statement: print leap year, else print non-leap year. This is the way of validating the algorithm. So once an algorithm is designed, we need to ensure that the algorithm should produce the correct results for all valid inputs. In our case, 2000 is a valid input, 2100 is a valid input. So here when you give right to 2100, what happens? So 2100 mod 4 is equal to 0. 2100 is divisible by 4. 2100 is not equal to 0. We are checking. It should not be a century year. But 2100 is a century year, right? So first condition, year mod 4 equal to 0, right? True. And year mod 100 not equal to 0, right? False. This indicates that this condition determines, right, if the year is century year or not, right? Here, so clearly here 2100 is a century year. So checking the OR condition, year mod 400 is equal to 0, 2100 modulus 400 is not equal to 0, since 2100 is not divisible by 400. So clearly the else part will get executed. This results in a non-leap year. This results in a non-leap year. So whatever the valid inputs are, we can say for all valid inputs, the algorithm should produce the correct results. Then only the algorithm is said to be validated. So validation of an algorithm, right? This is one important areas of study. Third one is how to analyze the algorithms. This means algorithm analysis. Are said to be the term performance analysis. Performance analysis refers to the task of computing how much storage and how much computational time is required for an algorithm. Performance analysis determines how much computational time and how much storage, that means the space complexity and time complexity. Focusing of space complexity and time complexity is the performance analysis of the algorithm. When the algorithm gets executed by the machine, how much storage is actually required, how much computational time is actually required, right? That is the part of analysis of algorithms, or algorithm analysis, or simply the performance analysis of an algorithm. This is also an important areas of study of an algorithm. Fourth one, testing a program. Testing a program. Once an algorithm is designed and assuming that the algorithm is validated, then we need to find the space requirements and time requirements of the algorithm. Space complexity and time complexity of the algorithm are obtained. Then the algorithm is converted into a program. Algorithm is converted into a program, because already we have discussed that algorithm is nothing but the simplification of the program. So once the algorithm is converted into a program, we need to perform the testing operation. So testing a program consists of two important steps. One is debugging, second one is profiling. A debugging is a process of executing a program and to check if any faulty results occur. Check if any faulty results occur. This should be rectified. Rectify this in case if any faulty results occur. This is a normal process, right? Faulty results, right? This should be avoided. So this should be rectified during the debugging stage. Assuming that debugging is successfully completed, that means the program is working fine. Given the input, we are getting the expected results. Algorithm design, validation, performance analysis, in implementation, right? In implementing a program, debugging is over. Then the last stage is profiling. Profiling is also called performance measurement. Performance measurement. Performance analysis we have discussed, right? Performance analysis in the sense that this is a priori estimate. That means before the algorithm implementation, we need to estimate, analyze how much storage is required, how much computational time is required for the given or for the designed algorithm. That is a priori estimates, where performance measurement focuses on a posteriori testing. A posteriori estimates. That means after write a program, during the testing operation, we need to check how much computational time is required to run the program. Second one, how much space or memory is taken to run the completion of the execution of the program. These two are related with after implementation. That means these two are applied to the program, wherein performance analysis we have focused on the time estimate as well as space estimate, simply saying time complexity and space complexity for the algorithm. Performance analysis, in performance analysis time complexity and space complexity is analyzed for the validated algorithm, wherein profiling the time requirement and space requirement is estimated for the successful program. So estimating or simply computing, measuring the actual time taken to complete the execution of the program, measuring the actual space required to complete the execution of the program, right? This is profiling. So clearly saying, testing a program which comprises of debugging and profiling steps, also one important areas of study of an algorithm. So we have focused on the 4 important areas of study of an algorithm. One is how to devise algorithms. Second one, how to validate the given algorithms. Third one, how to analyze the given algorithms. And fourth one, how to test a program.